Hey guys, so today we're going to be looking at the 2021 Aime 1's number 5. So call a three-term strictly increasing arithmetic sequence of integers special if the sum of the squares of the three terms equals the product of the middle term and the square of the common difference. Find the sum of the third terms of all special sequences. So I'm just going to write down these three terms. Let's just pretend that those are the terms of the arithmetic sequence. X represents the middle term and y is the common difference because that's what makes an arithmetic sequence, it has a common difference. So this sum of the squares of the three terms, we're just going to add those up. This equals the products of the middle term x with the square of the common difference y. So this equals xy squared. So as you can see, assigning the terms x minus y, x, and x plus y is a lot smarter than just putting x plus y, x plus 2y. It cancels out some stuff, and yeah, we'll see later. So now let's just simplify this equation. X squared minus 2xy plus y squared plus x squared plus x squared plus 2xy plus y squared equals xy squared. And as you can see, the two xy's cancel out, which makes it a lot easier. So 3x squared plus 2y squared equals xy squared. So right now our goal is to find x and y that does go into this equation. So let's write y in terms of x. So I'm just gonna put the y squareds onto one side, which gets xy squared minus 2y squared equals negative 3x squared. So y squared times x minus 2 would equal negative 3x squared. So y squared would equal negative 3x squared over x minus 2. Something that would make solving for x and y a lot easier is making the constant a numerator. And we'll see why that matters later. So I'm going to just try to get rid of the 3x squared by dividing with the x minus 2. So 3x times x minus 2, that does subtract 3x squared. However, it subtracts an extra 6x, so we're going to have to add 6 times x minus 2, which subtracts an extra 12, so we're going to add 12, and that gives us y squared. Okay, so 3x plus 6 plus 12 over x minus 2 equals y squared. Now, as you can see, this is what we're going to be using. It makes it a lot more clear. Now we have values that we can try out for x, like a limited amount of values. So obviously, because x and y have to be integers, x minus 2 must be a divisor of 12, so it can be 1, 2, 3, 4, 6, or 12. Therefore, x has to equal 3, 4. Oh, by the way, notice that x minus 2 can't be negative because that would make the answer less than 0, and y squared, if it's a square, it has to be more than or equal to 0. So here are the values of x that are possibly going to work. Okay, so I wrote out all of the values of x, and only two of them, x equals 5 and x equals 14, results in y being an integer. Okay, so let's just test this out to see if it really works. So the three terms are going to be 0, 5, and 10. 25 plus 100 is 125, which is equal to the middle term times the common difference squared. So we know that 5 is going to be one of the options. Next one, the ordered pair is 14 and 7. So 7, 14, 21, that's our possible sequence. And if you add up the squares, we get 49 plus 196 plus 441, which equals 686. And the product of the middle term times 7 squared, that is also equal to 686. Therefore, x equals 14 is something, yeah, that works. So Now it asks for the sum of the third terms, so the third terms are 10 and 21, therefore the answer to Aime 1's number 5 is 31. Thank you.